All right, hello everyone. So today we have a differential equations problem. Solve the equation dy dx plus xy equals xy cubed. If we take a look at that equation, this has the form of a Bernoulli equation, which if you see in blue is equal to dy dx plus p of x times y equals q of x times y to the n. P and x or q of x are two functions of x. And the exception here, really, if you're using this equation, is really not meant for like n equals 0 or n equals 1, because if it's n equals 0 and n equals 1, it just goes back to solving a first order linear equation. And so just make a note of that. So how do we go about solving these equations? First thing we're going to do is we're going to do a substitution. And we're going to choose the letter V or whatever you want to choose. It's just V is kind of like the default usually with these problems. And what we're going to do is we're going to take V and raise it to y to the 1 minus n. So y to the y minus 1 minus n, excuse me. So in our case, our n in this problem is going to be 3, because that's what the y being raised to on the other side of the equation. So it'd be y to the 1 minus 3, or y to the minus 2. So we have that v equals y to the minus 2. All right, so what do we do with that? The next thing is as follows. We're going to go ahead and take a derivative of both sides with respect to x. So because v is y to the minus 2 and y is in terms of x, v is also a function of x. So this would be dv dx on one side. So we're going to be doing an implicit derivative. What's the derivative of y to the minus 2? It's going to be negative 2 y to the minus 3 dy dx. And what I'm going to do is I'm going to solve for dy dx, and dy dx would be y cubed over negative 2 dv over dx. And what I'm going to do next is going to take that expression I just got for dy dx, an equation, and I'm going to replace the dy dx in our original equation with that. So let me go back to our original. Let me do a quick copy and paste here. So where we have that dy dx, I'm going to replace that with that expression. So we'd have y cubed over negative 2, or put the negative in front, dv dx plus xy equals xy cubed. So everything else stays the same. And what I'm going to do next is this follows. I'm going to get the term d that has the dv dx in it. I'm going to just get the dv dx just by itself, and no coefficients in front of that dv dx term. So I'm going to multiply both sides by minus 2 over y cubed, and you would produce something along as you see here. So it'd be minus 2x y over y cubed equals minus 2 xy cubed over y cubed. And if we simplify this second expression here and that third one, you come up with minus 2x over y squared equals minus 2x. And one last thing here, I'm going to rewrite that 2x over y squared as 2x y to the minus 2, minus 2x. And why? No pun intended. Why am I doing that? It's because v, if you go back to what we let v equal, right over here, it was equal to y to the minus 2. And that's what we have here. So another way of writing this would be dv dx minus 2xv equals minus 2x. And this is a first order linear equation. That's what it comes down to. I'm not going to go ahead and solve the whole equation, because the purpose of this video was to just go over the substitution here that you make. But if you went ahead and did that, this the mu that you would have is e to the minus x squared. And this whole thing would come out to be v e to the minus x squared after multiplying both sides and rewriting that right-hand sound as a sorry, the left-hand side as a product rule comes out to be this. And if we integrate both sides, it'd be this plus c. And v equals, I'm going to divide both sides by e to the minus x squared, and this is what you'd come up with. And the reason I just wanted to go over that is just to make a point. You're not done yet, because we need to solve for actual y. So y was equal to y to the minus, v was equal to y to the minus 2, so I'm going to replace that in there. And if you went ahead and took the reciprocal of both sides, you get something like this. And if you take the square root of both sides, you get plus or minus 1 over the square root of 1 plus c e to the x squared, as such, okay? So that's how that method works. So that substitution that you make when you let v equals y to the 1 minus n turns your equation into a first order equation. Now, your other method here that you could use is by using a formula. And what I wrote here, let me highlight it. All this is the general way of getting the solution, getting your Bernoulli equation to look like a first order equation. So v would equal 1 minus n, and yeah, n here stands for any power. dv dx would be the derivative of that. And then I solved for dy dx. And then what I did was I plugged it back in. I plugged the expression for dy dx back into the original equation, which was like this one. So again, this is the general form. And you get something along these lines of what you have here. So if you have something that's in the Bernoulli method, what I'm saying is that you can kind of just put things into that box that I have, and you can, and just don't forget of writing that substitution that I have here in blue, which is v equals y to the 1 minus n. In other words, if I took the equation that I had earlier, I would turn this into 1 over 1 minus 3 dv dx plus p of x here is x times v equals cube x just x. And that would be my equation, which I would solve. And I would not forget that on my substitution again would be v to the minus 2. Okay, so that information you can plug it in directly. The only, downside to this, in my opinion, is you have to remember a formula, which I don't want to do myself personally. I'd rather just derive it. Okay, all right, well, thank you for your time. Hope this helps.